Welcome back to my YouTube channel, Yajin Salim TV. Welcome my friend. Make sure you don't forget to subscribe the button below. For more updates, for more notification, so you'll be the first one to watch the current video. So welcome. Today I proceed with the determination of the discharge of flowing liquid through a rectangular notch. Okay, determination of discharge through rectangular notch. So let us start. If you remember very well, in my previous video, I defined the meaning of the notch. So today let us proceed. This is a sketch. This is a sketch. This is a structure. Then this is a channel. The water is flowing. In these channels. Is flowing the water. This one, as I said in the previous video, this is crest or sail. So the water is passing through the notch, this notch, which is rectangular. So you can see the height of water in the upstream side. This height we call the head of water, denoted by the capital letter H. So as we know, if you need to calculate the discharge of the serpentine shape, so first of all, because it's very difficult to calculate the discharge for the full shape, so we are starting for the small strip. Then after finding the discharge for the small strip, then we integrate, which we mean we sum up the discharge for several strips in order to get the total discharge for that shape. So for this channel, if you see, this is a side view. So right now, see in front view. For this one, you see like this. Then you have the free surface of water up to bottom here. This distance from free surface of water up to bottom is capital letter H, as I said earlier. So this is our channel, the section of our channel. So let us find the discharge through the small strip. Let's our strip be like here. This is our strip, which is horizontal strip. So we have a distance from the free surface of water up to the horizontal strip, which is H. But also we have the bleeds of this channel, this notch, which is denoted by letter L. So let us proceed, because we need to determine the actual discharge which is flowing through this notch. So the actual discharge, in order to get the actual discharge, we are from the first principle. We know the coefficient of discharge is equal to actual discharge over theoretical discharge. We get the coefficient of discharge. So it means to get the coefficient of discharge is equal to the delta, change of actual discharge over change over theoretical discharge. So it's delta Q over delta TH. This is the actual discharge and this one is the theoretical one. Actual discharge, it means the visual one, the lily one, the lily discharge, which is passing through a certain channel. But the theoretical one, I mean, you are using the formula in order to calculate that discharge. So in order to get the theoretical discharge, the Q for the small strip, then it will be the coefficient of discharge times the delta D theoretical, as we know. But D theoretical, it means it's equal to velocity times area. But because we are dealing with the small strip, and that strip has its own thickness, which is delta dh, so now you can see the variation in the thickness of this strip. So the velocity will be the constant. So in order to get the dqt, it will be velocity times the change of area, which is the area. Yeah, to get the area of that small strip, you will see the small strip as its L leads times its thickness with dh. So in order to get the dA for the small strip, for that horizontal strip, it will be L times dh. I hope we are together up to now. Simply, let us proceed. So now to get the D theoretical, it would be velocity times L times dh. But the velocity, how do you get the velocity? Because this is a channel, so it resembles this velocity is the same as the velocity inside the tank. For example, your velocity inside the tank, here there is a small opening. Assume first of all this tank is closed, so you have the water, then you have a distance, or you have this height of water from the bottom of the tank up the free surface of water. You have a small distance h. This is the height of the water. So if you close this, so the water is not allowed to pass through, there is energy which is possessed by this water due to its ON8, which is potential energy. And potential energy equal to mass of that water times gravity, then times the height of that water. But if you allow this water to pass through this opening by a certain velocity v, as we know, the energy is converted from the potential energy up to the kinetic energy, because energy is never lost, but it is created from another form of energy. So the potential energy, it will be equal to kinetic energy. So the potential energy, it's mass times gravity times h, but the kinetic energy equal to half mv square. So you'll make the subject the velocity v. Here you get 2gh in square root after making the subject v. Yep. Wow. So now our velocity is the same as this velocity in this tank in a small channel. So now dq theoretical, it will be velocity which is equal to 2gh square root times length times dh. Wow. Now to get the actual discharge, it will be cd dot d theoretical, which is equal to 2gh, then a square root times L times dh, then dq, it will be cd dot L dot 2g in radical, or in square root times h in square root times dh. This one times this one, you back here, so it's the same. So now dq, it will be cd dot L dot 2g in square root times h, this is the same as you put power half times dh. So now let us proceed. Now dq equal to cd dot l dot 2g dot h power half dot dh. But remember, we have a strip, this small strip, which has a thickness dh, then you have h up to the free surface of water, then you have full h. So we need to get the full discharge which is passing through this notch. So you have to get the full discharge, it means we need to sum up. To sum up, to integrate. The way you integrate, it means you sum up, you adding that small strip or that several strip in order to get the total discharge of this opening. So let us come here. So now I will integrate, I will sum from the discharge equal to 0 when there is no discharge here up to the center discharge which is q, the same as here. I will integrate because this all be constant, so I will integrate this HDH from 0 up to the maximum, up to the H, the capital H, which is the head of water. So I integrate from 0 up to H, capital H, here 0 up to the Q to get the value. So if you integrate, because this is the same as if you integrated dx, the principle from the integration dx, you get x plus c if there is no limit. So now we have the limit, so integration for dq, you'll get to q. Our limit is 0 up to q. So here it will be the constant cd times l and out to 2g. Then the same as this one, h power half, the same as if you have the integration for x power n, it will be x power n plus 1 over n plus 1 plus c if you have no limit. But if you have the limit, then there is no c. So after integration, this one you get h a half plus 1 over half plus 1, then the limit is 0 up to h. Here we enter, we starting with upper limit which is q minus lower limit. Now q equal to 0 minus 0, cd dot l dot 2g square root, here you get h 3 over 2 over 3 over 2 0 up to h. Now q minus 0, you get q. Here 3 over 0 is a constant, so you get 2 over 3 cd dot l dot under root of 2g times h 3 over 2 0 up to h, the limit. So now q it will be this one 3d l and out 2g dot. Now h, we are starting this upper limit. Now h equal to h capital, going to be h 3 over 2 minus lower limit which is equal to 0. So now q it will be this minus this one, then you get 2 over 3 cd times l times 2g, then times h 3 over 2. So now the discharge of a rectangular notch, it will be 2 over 3 coefficient of discharge times the length of that notch times square root of 2g times head of water power 3 over 2. So this is already done. Very simple. So thank you for watching my video. Thank you. Welcome next time. So if you have any question, write in the comment below. I'll try my best to answer every question which will appear. Thank you, my friend. Just welcome.